Okay guys, so just in the previous video we looked at calibrating the data. What does that mean? That means we took data from this graph or this table down here that was in a sense meaningless information. It was obviously full of meaning. It carried a lot of information, but it didn't have any real world application. For example, we were looking at frame numbers as we kept looking at different frames. This kind of referred to the time. So each new frame was a new point in time. But then we also measured the person's position based on these pictures. And so the person was 2.5 millimeters from the edge, 3.8 millimeters from the edge at the next one. But in real life, we don't walk 2.5 millimeters and then 3.8 millimeters. We walk in perhaps half a meter per step, perhaps if you're running, a meter per step. So we needed to convert this into a real life meaning, into real life data. So that's the previous video. But I just wanted to show you that the original graph using frame number and distance from the edge, there is frame number 1, and there would be your 2.5 millimeters from the edge. There's your frame number 2, and you would be 3.8 millimeters from the edge. Frame number 3, 5.5, yes, etc., etc. And then what we saw was our conversion factors, that we made the assumption that here, if that is 2.5 millimeters in the picture, using this distance, then we made the assumption that in real life that's actually 1 meter from the edge. And so we had this conversion factor, 1.0 meters over 2.5 millimeters. That is our conversion factor. And if we wanted to convert these millimeter distances to the real life value, this was our conversion factor, and we multiplied, say, 3.8 millimeters, and we got by this conversion factor, and we got the 1.5. We multiplied the 5.5 by this conversion factor, and we got the 2.2, etc., etc., etc. And so the other thing is that we made the assumption that the first frame is time equals 0, the second frame is 0.33. Okay, this was not an assumption. The assumption is that the first frame is 0, and then we know that each subsequent frame was a third of a second in addition. Okay, and so basically we converted this into this. So we're saying now at the first frame was time equals 0. There we go. There's the first frame. And where are you at time equals 0? Well, where is the man at time equals 0? He was at 1 meter at time equals 0. And where is the man at 0.33 seconds? He is at 1.5. There's 1.5 there. And then at 0.66, he's at 2.2, right? And then at 1 second, he's at 2.8. Okay, so that is pretty straightforward. And that is basically all that I'd like to cover in this video, just to see how the graph then was drawn from this data. Okay, in the next video, which will also be a very short video, we will look at how we can actually change the origin. The origin can be arbitrary, but it doesn't change the relative position. Okay, see you in the next one.